where we see the usefulness of a multidisciplinary approach. We're talking about non-communicable diseases, and I'm sure that the audience we have today is familiar with the definition of NCDs and the fact that they have a common risk factor pathway. Really, the essence of the presentation today is the fact that we do need to have a multidisciplinary approach. Next slide, please. And the context that I'm taking is one where if we're going to tackle NCDs, so we know that we have this twin or sometimes even quadruple threat in terms of the burden of diseases. One of the major constraints we have is the amount of resources that we can apply to our healthcare. So I've just put that up just to give a comparison, that in Kenya, we're spending about less than $100 per annum on healthcare in total. And if you compare that with the US, which is something close to $11,500, you can see that we have a huge gap or huge difference in terms of the amount of money that we can spend. Now, when it comes to non-communicable diseases, we know that once they begin, it's a lifetime thing. So, and a lot of it has to do with diagnostic tests and even the treatment and so on. So we do need to think a little differently, because we cannot just import our treatment protocols together with the equipment that is needed and all the tests wholesale. We have to think a little bit about how we're going to manage this, particularly because of the life course that NCDs have. Next slide, please. So typically, when we think about multidisciplinary teams, and I know that we've had these kind of discussions before, we tend to think about it within the context of a hospital, and we tend to think about it limited within healthcare, and we think about the different cadres. So we tend to think a multidisciplinary team consists of basically the clinical care team and maybe just a few auxiliary members. So we think about the doctor, the nurse, maybe the lab technologist. Sometimes we think about it from the perspective of the radiology or the diagnostics vis-a-vis the people who are doing bedside care and so on. So it tends to be, yes, it is multidisciplinary, but within healthcare, and often very narrowly focused within the setting of the organization. And yet, a lot of the frustrations that we have in terms of care are slightly outside of this narrow multidisciplinary team. So many of us will have this frustration of we can't get, the procurement is all messed up and there's a shortage of this or a shortage of that, or there's a delay in getting this particular bit of something, and so on. And so one of the things that I'd like to pose is that we do need to widen a little bit what we term as multidisciplinary. So when we think about the team, can we start to think outside of the confines of the clinical care setting and think a little bit wider about how should we define the multidisciplinary team, and how do we set up means to communicate some of the needs within the clinical care outside to others who would then be part of this team. So typically, when we're thinking about a multidisciplinary team, we'd be thinking about some of the issues. We think about the context within which they're working. So like I said, we tend to think narrowly in terms of geography. So we think that the team should just consist of the people who you see and can sort of, non-COVID, you can sort of touch and feel every day. And a lot of it has to do with the human resource policies around, and also how people get paid. So we have differences between, say, private sector and the public sector, in the sense that private sector, a lot of things are fee for service. So when we're thinking again in terms of the diagnostic side of it, the medical equipment side of it, when it's fee for service, what we do is that you just take the cost of whatever machine you have and you add a margin on top. And then we have issues about how the patient is going to pay. When we think about the organizational context, it tends to be that some of the issues are, one, the goals of the organization. So we're in KNH, for example, and that's public sector. So the goals are a little bit different from a private sector, what can be done and what can't be done. And then there's a big issue, which I think is something that we need to tackle around the information system. So the frustrations we have when something is missing or something is not there, how do we pass that information along? And how can we change that? And then lastly, the team structure, depending on the type of patients that we're seeing. So we're talking about NCDs, and we know that these are people who come repeatedly. They tend to be, for a lot of what the kind of patients that are seen, they tend to be that they are going to be middle age or elderly. So there are issues around that. And then lastly, what I'm going to talk a little bit more about, the roles of the various team members. Next slide, please. So I thought I'd just put that by way of context. So I've talked a little bit about the financing, that we have very little money that we have to manage the issues that we have, particularly non-communicable diseases. And we're trying to have good service delivery. Now, a lot of the costs that we have in healthcare are going to be driven by the kind of medicines and technologies that we have, and the kind of governance structures that are present that either allow or don't allow us to do various things. So because we're going to have this talk about engineering, I thought I'd focus just about the medicines and technologies. And if we have what I would call a lazy approach, where we just import wholesale technologies from outside without evaluating them properly, then we're going to have a really huge problem. We already have, but we'll have a bigger problem in the future. So we need to begin to think about this, particularly in the context of NCDs, the kind of technologies that are appropriate for us and that work in our context, but are also affordable. And then we have to think about the kind of human resource that can operate these technologies. If we're able to save in terms of our medicines and technologies and how we organize our information, then we can make do with the human resource that we have. Next slide, please. So I'm coming to the point where I'd just like to summarize a little bit why a multidisciplinary approach is useful, particularly for NCD care. We know that for a lot of patients with non-communicable diseases, they end up being in a situation where they have comorbidities or multiple morbidities. So we have this big problem of the kind of equipment that they need, medical equipment, and to support the kind of care that they need. If we can develop a system where we have good teams across disciplines, particularly engineering, then we're looking at a situation where we can have standardized equipment. So rather than having even one facility with many different types of equipment doing the same thing, depending on the phase which it was bought and so on, we have greater standardization. And that would, if you're looking at the lower bit, also look towards improved quality of care. And that would also contribute to equipment that is better suited to the kind of personnel that we have. Now, that requires us to have improved understanding of the clinical and equipment needs. And here there is a challenge. Now, I've just been part of a project for about the last 4 or 5 years where we have been innovating around medical devices. And one of the very interesting outcomes of all this has been that for probably, well, at least the first time we've had this situation where we've brought in engineers into KNH, particularly, and also other health facilities, has been this language barrier between people who are in a very clinical setting and people who are outside. And it is surprising how the languages are very, very different. Yet we can get quite good improvements in terms of clinical outcomes just by getting people with a different perspective to look at the problems within healthcare. So this bit about understanding the clinical and equipment needs and the language that is required, so that translating the clinical frustration into language that an engineer can understand is a critical part of this. And that would help solve some of the issues that we see in the back office before you reach the point of the patient, which is improve logistics, so reduce delivery time. So between the time that something is required and the time that it reaches the bedside would be reduced. And what we're trying to get to is the point where we get lower costs on the back of better product selection. So we don't buy stuff. It reaches our country, we install it, and then discover that it isn't the right equipment. So we need that interface with our engineers. And the last bit is the big one, which is the bit about the maintenance system. If we have these interactions and we have this multidisciplinary approach, then we're able to improve our ability to plan for better outcomes in terms of the equipment that we need. And this would be on the back of improved skills for maintenance and also calibration. Part of the project that I just mentioned, the Maker project, we did install the first calibration unit in KNH, which is now functional. And this was actually a surprise because prior to this, we'd have equipment that would go for many years without any sort of calibration. So you really don't know whether the machines that you're using, from just the basic BP machines all the way through, have been properly calibrated over time. Next slide. So in conclusion, we do need to have a multidisciplinary team approach, and we need to have it a little wider than the traditional way that we think of just the different cadres within healthcare. And the idea is that it's not sustainable to have a vendor-led approach where we import and then have to adapt to expensive machines that come from outside of the country. So we need to begin to think for NCD, how can we have our own machines that have been adapted to our own situation? So I think that's the last slide. Thank you. So what I'd like to do is, with the permission of the facilitators, is to introduce Professor Madara Ogot. If you can remove the slide. Is to introduce Professor Madara Ogot. He's a professor of mechanical engineering. Actually, he's a double PhD in mechanical engineering and also business administration and strategic management. He's widely published and has been DVC here at University of Nairobi in research, and also DVC at Maseno for academic affairs, and also for a while was director of research at UoN. He's based at the Department of Mechanical Engineering, and recently we have been collaborating with him, not just on this Aurora, but also on putting together a medical device, an oxygen concentrator. So, Professor, the floor is yours.
Okay, thank you. Good afternoon, everybody. I'm hoping I have powers to share my screen, if I am able. I'm trying to bring it up. Am I able to share? It's not allowing me to share. The host, do I have powers?
Yes, you can share your screen.
Okay, let me try again. Okay, share. It's not allowing. Okay. It's not allowing me to share. Richard, maybe I suggest we skip to Anne, and then I can email it, and it's projected for me.
Yes, you can email it to knhresearch@gmail.com, and we'll be able to project it for you.
Excellent, thank you.
Yeah, so just like while we wait for that presentation, I'd just like to introduce Dr. Anne Kamau. She's a researcher at the Institute of Development Studies, IDS, University of Nairobi. And she's also the director for Aurora, the NCD Center of Excellence. So to just say a few words about what the objectives of the center and where we're at in terms of the project. Dr. Kamau?
Okay, Richard, and good afternoon, everyone. And we welcome you to this webinar, and we are really grateful to have you here. I'll just say very few words regarding the Aurora Center of Excellence for Non-Communicable Diseases. The center we had presented some time back last year, but for those who were not there, the center is one of the 13 centers of excellence of the African Research Universities Alliance, whose secretariat is in Accra, Ghana. And our center is on non-communicable diseases. And mainly, we hope to be able to build a center of excellence, focusing mainly on NCDs, but more importantly, also enhancing their capacity, especially of postgraduate students in NCD work. That means that as a center, we are quite keen to bring as many postgraduates as possible on board to participate in their work activities, in the center activities, as staff across all disciplines, again to participate. And this is not just within the University of Nairobi, but also across Africa. At the moment, the center is made up of 5 what we call research-intensive African universities, with the hub or the center being hosted here, the University of Nairobi. But others include Makerere University in Uganda, the University of Ibadan, University of Ghana, and University of Witwatersrand. And we have lead partners in each of these countries. So for us, we are hoping that beyond the 5 African countries, we are also going to be able to reach out to other, what is called the non-research intensive universities, including our very own. For example, we have Jomo Kenyatta University on board, and we are hoping also to be able to reach out to other research institutes within Kenya and beyond, and in each of the regions, so that then we build a strong network of persons or specialists or even individuals who are participating in NCD research. Some of you might, for example, know the NCD Alliance, and which is one of our members represented by in the board, advisory board. So, and this is really what we are hoping to reach out to and to achieve. Now, just quickly back to the topic of the day, which is about multidisciplinary engagement in NCD work. From where I come from, I'm a social scientist, and more focusing on issues of adolescence and health, and therefore drawing from a life course perspective. And to build on to what Richard has said, what we know and what we believe in is that when you look at the whole spectrum of NCDs, it can be traced from as early as childhood, depending on many sociological, environmental, and even anthropological factors. And these are the things that we need to take care of if you deal with NCDs later in life. So what we see in the hospitals is a reflection of what we have out there in the communities and in the society. And we need to be able to work in a system that enables us to not just work within the hospital settings, but more importantly, even at the community level. And understanding that NCDs are broad. They're the big 5 that Richard calls. We have the hypertension, the cancers, and all of that, but including also the mental health issues that are critical in terms of even the contribution to other NCDs. For example, depression is one of the conditions that may lead to even, for example, increased alcohol intake that might eventually lead to, for example, liver conditions that then, would have all those other negative related outcomes. So this broadly is what we're focusing on. At the moment, we are implementing a capacity building program, which is already funded by the UKRI. And in this program, we are, in addition to undertaking research to understand the NCD situation in the 5 countries, we are also supporting 2 grants, what we call the mini grants. One being taken jointly between University of Nairobi and Makerere University, and one between University of Ghana and University of Ibadan. And presently, we are hoping that we can roll out another one, a third one. So we do encourage as many as would want to participate in our activities to get in touch with us and to become members of the NCD network. And Richard, I wish to stop there and also call upon Professor Mandara to continue with the presentation. Thank you.
Okay, thanks. I think I've sent the slide, if it can be hopefully projected. Excellent, yes. I'm not sure why it didn't allow me. Good afternoon, everybody. Sorry for that delayed start to the presentation. For me, it's a pleasure to represent to a medical community. I'm from mechanical engineering, as was said earlier, and it's not often that we do have this interaction. But as Richard said, we have been working on quite a number of projects, and it shows that in many areas, as hopefully I'll show in the brief presentation I have, that really to be able to succeed, we need to be able to work together depending on the perspective that we are coming from. Next slide, please. So we will focus on the area of oxygen availability, and this is something which right now COVID, of course, has made it crucial, but we were looking at this primarily from the context of non-communicable diseases, the need for oxygen therapy for the various other non-communicable diseases, but of course it is a cross-cutting issue as well. And one of the things that attracted us to this is the fact that it affects children quite a bit, and it's a major risk factor for death amongst children as well. Many ways a hospital can get oxygen, either the larger oxygen plants that are built at the hospital itself, through oxygen cylinders, or through smaller oxygen concentrators. Just for the audience, the larger plants that you find being built at hospitals are just simply large oxygen concentrators, and then use that to fill the oxygen cylinders on site. Next slide, please. In a low resource setting, is that although hospitals say they have oxygen, the supplies are often limited due to lack of resources, sometimes just to fill the oxygen cylinders. In Kenya, as you saw a few months ago, just lack of the cylinders themselves. And even those who have oxygen concentrators, a lot of them tend to be broken. Next slide, please. So what we're trying to achieve through this interaction is how can we get oxygen, make it more available to our community, especially in rural areas, but with equipment that is high quality and user-friendly, that is also targeted to the environment within which they operate. These tend to be hot, dusty, humid. And again, most of the equipment you can buy were not designed or built for these environments, and they end up breaking down relatively quickly. Another key thing that you find in the literature is that most of these equipment will break down, all the equipment does, but then they're not easy to repair, simply because there may not be adequate staff qualified to repair them. And the issue is this: different manufacturers make the equipment in slightly different ways. And you can find even a single hospital has equipment for multiple manufacturers. So it's unlikely that even that staff member on board would be able to repair all the various different types that are there. And even when they can, spare parts tend to be very difficult to come by. Especially when we're talking about the oxygen concentrators, a lot of them in our hospitals were donated. So they come from many different countries. During that process of donation, the issue of maintenance and spare parts was rarely in the conversation. But what we're saying is, because these equipment run pretty much 24/7, there need to be a pipeline to make them easy to repair when they do break down. And a key factor of that is the availability of the spare parts. oxygen should be affordable to patients. And that's one of the basic premises that we are coming from. Because where you find it's expensive, you either have the patients discharging early because they can't afford it, or a lot of times not even getting the treatment they need because they simply can't pay for it as well. Next slide, please. So before we embarked on our project, we wanted to find out that what is the current status of oxygen availability in Kenya. So in November last year, 2020, we carried out a survey within 11 counties, and we surveyed over 210 hospitals across the 11 counties. And we just asked them those basic questions that you see on the screen. Question number one, do you have oxygen for the patients? If the answer is no, the survey ended, right? If you do, then the next question was, in how do you have it in all the forms? Is it cylinders, piped oxygen, concentrators? And then depending on the options you pick, we asked, what are the main challenges you're facing with the cylinders? What are the main challenges you're facing with the concentrators? And the last question, we just wanted to have an idea of, for those who charge for oxygen, how much are you charging? So again, here we're looking at the patient price, not the cost of the hospital. What is the price that the patient actually sees? Next slide, please. Oh, next one. There we go. Oops, so just go back one, please. Ah, it's blank. Okay, next, let's go to the next one. Seems to have skipped a slide. So when we looked at the different sources of oxygen that you find within, we found that it's a mixture. The lighter green is what is the private hospitals, the bluish is the public, and by far those who actually have oxygen, the highest percentage is piped oxygen for those who actually have it, more in the private hospitals, about 50%. And remember, here's a case where I can have multiple of them, not just one. So the top ones are those who have concentrators only, cylinders only, piped oxygen only, and the lower ones are the different combinations. Next slide, please. We also asked them, what are some of the challenges that they are facing? And those who have oxygen cylinders, and these were 72 who expressed challenges, the number one was simply the availability and access of oxygen for the cylinders. Some of the answers that were given, there were long periods between refills. So I have cylinders, but they're empty. Others were inefficiency in getting a new supply of oxygen. So that was the number one challenge. The second challenge was that they ran out relatively quickly. And of course, this is a frustration if you're constantly changing oxygen cylinders as well. The third one, as one can expect and has seen them, is that they are heavy, difficult to move from one place or another, or carry, or portability. And the last major, there were others, just the four top ones, was simply the cost. Sometimes the cylinders or the oxygen runs out, and the hospital doesn't have funds at that point in time to order the refill. Next slide, please. Those with concentrators, the issues were a little bit different. The first one were maintenance issues, and this is also supported in what you find in the literature. And this is simply the fact that they fail to produce the level of oxygen that you require, or they simply malfunction, and they have to wait until they are repaired. The second one, as one would expect, is the loss of electricity. These are plugged in. When power goes, they stopped working. Most hospitals, the backup generators, when they have them, is only a certain part of the hospital. It's not every socket. And sometimes then, even if you have a backup generator, you have to move the patient and move the concentrator to a part of the hospital that is backed up as well. The other major challenge they felt with them is most of them are designed for one person, maybe two, and therefore you need quite a large number of them to be able to serve a large number of patients. And of course, that similar challenge applies with oxygen cylinders. And the last one was just simply the cost, that they're expensive. But as I mentioned, the majority of them are actually donated as well. But for those who bought them, the cost was expressed as a major challenge. Next slide, please. So the issue of how much do does oxygen cost? Over half the hospitals don't charge, 53% say they don't charge for oxygen. And about 50% or so, 49% do charge for oxygen. What is interesting was the range of what is charged to the patient. It went all the way from 9 of them charging anywhere between 500 to 1,000 shillings, all the way to 6 of them charging over 30,000 shillings. This is for 24 hours of oxygen, yeah, independent of the source of the oxygen. Yeah, so you see this huge gap between the lower end and the upper end. Initially, we thought that this was public and private, but you find that some private on the lower end and some private, actually most private are the ones also on the higher end. Next slide, please. There's one slide, I think the blank one, maybe I'll just verbalize it. I'm not sure why that slide was missing. But the blank slide was starting off the point of who has oxygen. And we found that about 49% of the 200 plus hospitals, and here we're surveying level 2 and 3 hospitals only. Our assumption was that a level 4, 5 will have oxygen. This is just 2 and 3. About 49% did not have any oxygen at all. So those percentages you were seeing on pricing and so on are for the other 51% who actually have oxygen. And of those 49% who didn't have oxygen, the majority were government hospitals. And again, one can speculate on the reasons for that. Informally, again, many of the respondents were unwilling to give us official reasons for obvious reasons of victimization, etc. But what was coming out was that being free makes it not be there. The fact that many are required not to charge for oxygen as a public hospital means the resources available to the hospital are lower. When it runs out, and they just don't have it, simply because of lack of funds to do that. But again, that is anecdotal. We didn't get hard data on that. So part of our task, therefore, was, can we come up with a locally constructed oxygen concentrator? So it's design, build, prototype, medical grade oxygen. It needs to be robust, easy to transport, store, and use, easy to maintain, meets all the World Health Organization standards, and it's green design, which in our context is the minimal use of plastic. Most oxygen concentrators now you get, the casing and most of the structural components inside are plastic, which means at end of life, you now run into a disposal issue. Next slide, please. So here is, and we're using students as well with our team. So here is what the concentrator looks like, both on the outside and the inside. The components were sourced from various vendors as well. The casing, the structures, and putting it all together was all done at the University of Nairobi. We chose to have a metal casing. The idea being simple, that you can take parts in and out as they break. And when you reach end of life, you can either recycle the entire casing as metal, or you can put in new components and continue use in the same original steel casing. It was designed as a trunk, which closes on the top. So it's easy storage, easy transport, dust-proof, etc. So all access is from the top. Next slide, please. We're able to run it. Here's just a chart of one of the initial flow rates of oxygen concentration versus flow rate. We're able to get those much higher. These are some of the initial ones that we're just testing out that everything works. Next slide, please. Then we had a stakeholder engagement on this with members from the medical community in December. They made several suggestions on the design. The key one was on the orientation, that the original just occupied too much space. The original also required you to carry it. It didn't have wheels. The current design, we literally just flipped it on its side to a large degree, reoriented parts on the inside. It now has wheels on the bottom as well. So this is the current design that we are finalizing based on the design changes that were suggested from a stakeholder engagement in December. Next slide, please. I think it's the last one. And so where are we? We are also creating a version in that design that has a lithium-ion battery pack backup in it. So it should be able to run for up to 8 hours if the power fails. The backup version, because of the type of battery being used, lithium-ion allows you to have high energy density. In simple words, it means that it's a small package, but can store a lot of energy in it, as opposed to conventional other batteries, but it also costs a lot more. But our view was that the size is important. You don't want something very big. At the same time, being able to run for 8 hours should hopefully be sufficient for power to be able to come back as well. But it does increase the price, the cost, by about 50% for that particular version. We are finalizing the design as we speak. It should be done by end of next month. It's in the what do you call it? The fabrication stage. We have contracted out to commercial fabricators in industrial area to do this for us. And then we put it all together. We plan to have another stakeholder engagement in June with the revised design, again, to get more input. If all is well, we'll take it to KEBS for another certification that as are required. We began that process already. Once that is done, which we hope by July, August, that will be complete. And then working again with the medical team, we'll then have 6 devices that we will give out and have them run for several months and see how they pan out before we see then how we can upscale this and be able to produce them in mass. And I think that is the last slide. Next slide. Yeah, thank you. So I'm open to comments and questions. Richard, back to you.
Yeah, thank you very much for that. I think to Dr. Nancy, maybe you can handle the bits on questions and any comments.
Yes, thank you so much for the very interesting presentation that we've had. It's been really interesting to hear what is happening even within the country beyond the scope of the hospital. So what are other people doing to support quality healthcare within our facilities? There's a question from Mr. Zakaria Kimengich. And the question is, we have so many people who are trying to come up with innovations to solve a local problem, but then where do they get support? How would you encourage them to be able to get either the financial or the technical support to be able to advance their innovations?
Okay, maybe I can take that. And let me split that into 2, on the technical and the financial. And then in the context of the medical profession, it's even a third leg to it, which is the regulations and approvals and certifications that tend to be more than in other areas. So I'll start off with the easiest one, which is the technical. And here I would strongly encourage members of the non-academic community to partner with us in the academic community to be able to partner and come up and work with you on your technical issues. We are trying to build these partnerships even the other way around. Again, in the academic community, we have ideas, but we need to involve other non-academic partners, excuse me, the practitioners, for example, like we did in December, to be able to move any of these products to be able to reach a commercial level. So that would be my suggestion, to try and find the right people, partner with them from the academic institutions to help you with the technical aspects. In terms of financing, the second leg to it, this is a very big challenge. Even we are facing it right now. We got initial funding. Oh, sorry, I should have mentioned, our project was funded by the Open Society Initiative of East Africa. We were able to get some funding for last year, and we are very grateful to them. But their funding was to get a prototype built and tested, which means by the time we finish our work, end of June, July, they're done. That was their work. Our goal now is, and once the clinical trials prove to be effective, is we will also be in that same dilemma. Who is willing to fund to grow this? We're in the university, we're not in the business, for example, of manufacturing and selling. So in our case, we'll be looking for partners to do that. Here's a device, fully tested, has all the certifications, license it and go and make it and sell it, because that's what you do. We don't do that in the university. And you may find that there are many innovations that individuals may have who are in that position where it's a good idea to find a partner who will license your innovation, because they have the manufacturing capacity and the sales channels that you don't have. The only thing I would say before you even begin to do that is to ensure that you have protected your intellectual property. The world over, and Kenya is no exception, it's very common for people's ideas to be stolen from them. You got a very good open heart, open mind, you're selling an idea, you think this person is interested, before you know it, they've run away with your idea, but you have no document protecting it, which means in theory, nothing stops them from running away with the idea. You willingly went and gave it to them. So that's the one area that I would strongly advise, that before you go out to look for any partners, even in the university, make sure you've protected your work, and then you make sure that we sign what I refer to as non-disclosure agreements, which means that even if I'm not interested, I will then not go reveal your work to others who may then end up stealing your work. Thanks.
Maybe I could just add something to that. We've also had local manufacturers get in touch with us. And like right now, we have one manufacturer who is very interested in putting together a clinical trial for a device that they came up with. So you can imagine that they previously, and this is the problem about the medical device regulations, previously they were just used to making something, getting KEBs, and then putting it out on the market. And then they discovered, actually when we presented to them, that they have to go through some clinical trial. So now for them, that's a new learning thing. So it's also the other way around. It's not just people in healthcare making stuff and then looking for the market. It's the other way around, where there are people who have ideas based on what they see as a need or demand, and they want to find people in the clinical area who can help them navigate the issues around clinical trials. Thank you.
Thank you so much for that. I guess the question that is still pending is, where do people get the financial support? We've talked about the technical support and how to protect ourselves from ideas being taken away, but then how do you get the financial support?
Maybe I can take a stab at that. There is a vibrant community around innovation. One of them is called ASEC, looking at small and medium-sized enterprises and startups. So I can send the link on that. That helps people with that bit of looking for finance. So that's an example of one that's already there. It's actually got support from even the Ministry of Trade, but it's a volunteer group. Thank you.
Nancy, if you'll allow me, there are just some 4 quick questions I can just rattle through on the Q&A. There's the first one from Lucy Mbogo, says, I volunteer to participate in the clinical trial. Please get in touch with us. The second one is about the backup running for 8 hours. Yes, and that's why I mentioned that these are lithium-ion batteries. It's the same type of batteries you find in electric vehicles, electric motorbikes. So they're actually designed for high density. They can store a lot of energy, small package, and run for those hours. But as I said before, they cost a pretty penny. They cost on average about 8 times what the normal battery you find in a UPS is, the lead acid batteries are. But lead acid batteries are big, bulky, and et cetera, et cetera. So there's a price you pay for them, but they are getting cheaper and cheaper because more and more of them are being used as well. The third question is, do you have a way oxygen can be produced and stored for later use? And the answer is yes. The plants that are built at hospitals, actually, as I mentioned earlier, just larger versions of oxygen concentrators. And of course, those are now produced and stored in oxygen cylinders as well. And the last questions, as we have hospitals with broken down oxygen plants, why not get university to this initiative to at least get them running even as new innovations progress? Godfrey would be very happy to hear about this information. If you can get that to us through KNH, we can contact those hospitals and we can see what the issues are. The challenge is often you find that the major issues with broken down plants is simply lack of spare parts. Equipment was donated, spare parts can't be found. But I think it's a good idea and it's a good initiative for a partnership between the universities and the hospitals. Nancy, thank you. Back to you.
Maybe I can just add on that last one about broken down equipment. So yeah, so we have a pilot project ongoing right now in 2 counties, Kakamega, and we just moved to Kisumu, working with UNICEF and Philips, the medical equipment manufacturers. And what in that project, the first bit of it was to create an inventory of all the medical equipment in those counties. And so that register is now available, and there are moves now to try and get that up onto the DHIS. And the second bit is that University of Nairobi, the makerspace, we're working now to try and figure out whether we can make the parts, the spare parts locally. Is there a business case for making some of those spare parts locally? So we're working on that right at the moment. Thank you.
Thank you so much for the answers to the questions that have been raised up. There's an additional question from Dr. Diana Marangu, who's asking, how much is one of the proposed concentrators estimated to cost?
Okay, there are 2 versions, as I said earlier. The version without the battery backup, we're looking at a price of 50 to 60,000. And the one with the battery backup jumps to about 90 to 100. Now, take that price with a disclaimer. That is our development price because we are buying the parts at a very small number. We're buying like 8 of this, 5 of this. And so essentially you're paying retail to the manufacturers of some of those parts. If we're to scale this up where you're buying parts maybe 50 to 100, that price drops by about 30, 40% from what we are paying now, because now you're getting the wholesale prices. The second big component to it, and maybe there'll be a permission, is that 30% of that price is duty and taxes, even before you put everything together. Because even the parts are subject to duty, taxes, VAT, and all that. And it adds to about 30% of what you buy it for. So we are hoping that a lot of these hurdles will be overcome once we have a workable products in the market, and now we can make a case to government to waive. They may not waive all the fees and taxes, but to at least waive some of them, given that this is medical equipment and that we're actually boosting local manufacturing. But those are some of our target prices, which are slightly lower and within the range of what you can commercially buy before you import it.
Thank you so much for that. I'd like to give an opportunity to Dr. Alfred Osoti to be able to ask his question.
Thank you. Thank you for the great presentation and raising the concept of a multidisciplinary approach. One of the major causes of NCDs in our setup especially is related to obesity and lack of exercise. I'm wondering what the role of our engineering colleagues is as far as the built environment is concerned. Because you look around and you realize that children have nowhere to exercise, even adults have nowhere to exercise, Most universities outside there even have gyms within their campuses for their staff. But we realize that even in our own universities, most of the time, we don't even have the gyms where people can exercise after work or before work. So I'm wondering what the role of our engineering counterparts is on the built environment to help prevent NCDs specifically. Thank you.
Okay, thanks. And that's a great question that you raise. The challenge is actually outside the university. And I say that because within the built environment, the programs, the courses that they take in the architecture school, especially those who take the architecture undergraduate, those who take postgraduate, etc. All these areas are discussed. In the last 2 years, I've had a lot of interaction with architects on other projects that we have been working on. The challenge normally comes with the developer and the owners of facilities. And the reason is providing space for recreation, gyms, playgrounds, typically occupy space that they can use to raise more revenue, because those other spaces are seen as sunk costs. And so typically they will not provide them, or they'll provide something so that they can put it on a brochure that they have a gym. But when you go to the gym, it's the size of your typical bedroom. You know, you can't have 2 or 3 people in there at any given time, et cetera, but they can say they have them. So a big problem with the issues you raise comes primarily from the profit motive, that this space that I can use to better your health, I can make more money with it. But government is also just as guilty. It's not just the private sector, because the government also builds many facilities. And a lot of the same government facilities also don't have these spaces that you're talking about. So I don't have an answer for you, but I think it's just a bigger issue that should have a national discussion so that all the players involved can see the importance of having these recreational spaces to prevent NCDs.
Thank you.
Thank you so much for that response. Even as we are going through this discussion, and I'm just wondering, what is our government's or our facilities readiness in terms of adopting new innovations that come up? Because there's one thing about developing new innovations, and there's another where is our government ready? Are our health facilities ready? And if they're not, how do we get them to a point where they're ready to take up new innovations that will help in terms of patient management?
I think Richard may be better placed for that one.
I think I can just comment on that. The reality is that the medical profession is a very conservative one, and therefore if we use the word new and then use the word innovation in one sentence and then use medical devices, we're in trouble. So one of the things that we have been pushing for is that for a lot of the innovations that we're looking at, it's subtractive, in the sense that a lot of devices that come with a lot of stuff that we do not need. So we're not inventing stuff from scratch. What we're doing is that we're adapting it to our local needs. And often in doing that, we make it more robust and more affordable. So when it comes to certifying the device, whether at KEBS or whether at the Pharmacy Poisons Board, a lot of the approvals are already in. Then the next bit that then needs to be tackled is the bit about the demand, which is some ongoing work, which is to get the procurement people engaged so that they have the devices, as it were, on the catalog of what they should buy. We had a device, a previous device, the suction machine, that was the first to be locally designed and made in Kenya. And we got it approved. And then it sat for a bit until we got the ministry to take it up. So we have it on the list. Now, the catch, as Prof. Madara mentioned, is that the UoN is not a manufacturer. So even though the Ministry of Health called us for meetings and recognizes that we could be a manufacturer, actually we are not. So I think the answer to that is that, first of all, we have to go through all the steps and get it approved so that it is something that is shown to be safe. And then the next bit is to partner with local manufacturers and local suppliers of medical equipment so that they can be the ones to sell it. Then the facilities will take it up. Thank you.
Thank you so very much for that answer. And I think it's a high time from our spaces, wherever we are, to be able to take up and to think about the innovations that are coming up. There's this one that's coming up, and there are others that will come up, and be ready to be able to accept them even within our facilities to be able to better health and patient care. We are coming to the end of this webinar presentation. I cannot see any questions, but unless anyone has a question to ask, you can type it at the Q&A. It's been a really interesting presentation, and these are presentations that make you sit back and think, what, besides what I'm doing, what more can I do to help improve our country, to help improve patient care, even within our own spaces. And it's a really inspiring presentation that we've had today. So thank you so much, Dr. Ann Kamau, Dr. Richard Aya, and Professor Madara Ogot. Right now, I'd like to give our panelists a minute or so to give their parting shots, even as they come to the end of the presentation.
We can just go ahead. One is to thank everybody. And again, just to mention before that, we typically operate in our silos, but the last few years have been very exciting when we find that actually we all benefit each other if we work together. And this is a classic case where engineering actually, in my case, does play a significant role. From all the medical devices that are used in hospitals, they're all engineering devices. But we tend to shy away from the medical profession. So this has been an eye-opener that we actually do have a role to play and can contribute here locally. Thank you very much.
Yeah, maybe I can just say, yeah, for me, a lot of the within health, a lot of times what happens is that when something doesn't work, we walk away from it. Whereas the perspective I get from engineering, a lot of it tends to be that they want to tinker. And for me, that has been the side that, in a sense, is more exciting. And I'd really encourage people to ask questions. A lot of medical equipment, when you open it up, it's empty inside. The bit that works is very little bit of it. And what tends to go wrong is something very small. And it's within our purview to fix a lot of stuff. So I'd really encourage people to ask questions and to look for their friends who are outside of the medical profession and get them to ask questions so that we can solve some of these problems. Thank you.
Yeah, thank you. I think for me is to also say that there's need for greater engagement with the society and with the communities, even in the adoption of some of the devices, and more importantly, also in how we communicate with the communities. Just last week, I listened to the radio and those who were interviewed said, when we go to hospital, they tell me that my BP is on the borderline. It's 64 out of, and we don't really understand what it is. So again, as we need to deconstruct our communication engagement with the communities in the fight against NCD, and think of it as a life course issue, not a momental issue maybe or in adulthood, but it really cuts across the entire life spectrum. And I like the question on the role of engineering in the built-up environment and NCDs. And more to that is also to look at what are those things that you're also doing in the communities that actually are creating a problem for us in NCD. If you look at the transportation sector, for example, how much are we enabling our citizens, especially in the urban areas, to even walk or to cycle? because of the way we built our roads. So we need to really think about whom we are innovating for. Are we innovating for ourselves as professionals, or are we innovating so that then we benefit our communities and our society? And those are my final words, and I really thank everyone for participating in the webinar. Thank you so much.
Thank you so much to everyone, to our panelists for their presentation, and to everyone who's managed to actually join us during this discussion, and it's been an interesting discussion. Tomorrow we'll be having a mental health awareness presentation, and we'll be talking about just addiction. What is addiction? Addiction simply explained. And we'll have Dr. Changa Mareko, who would be taking us through issues of addiction. Also to highlight, we will be having a KNH-UoN conference will be held in October, and from 27th to 29th October 2021. And we are calling for papers. If you have done some research, done some work, and you want to disseminate that, we are requesting if you could send in your abstracts on those links that are provided and have been circulated even in your emails. Send us your abstract, and the abstract submission deadline is 31st of May 2021. However, the conference itself will be 27th to 29th of October 2021. Thank you so much to everyone who's attended. Have a good afternoon and enjoy your evening.